Hi there, everyone. Welcome to TensorFlow Everywhere live session. My name is Arshan. I'm the co-manager of GDG Cloud Community Islamabad. Just to give a quick, shout out. Let me know if you can hear me properly and the live stream is working perfectly. Just let me know in the comments and we can move forward. There will be a slight lag. All right, so we got our first comment. All right, so we are live. So just a short intro. I would like to introduce our guest speaker for today, Mr. Kemal. Kemal is working as the project director for the TensorFlow at Google. He's really passionate about solving the current problems that we have got using the AI and how we can actually solve these problems at a global and a very huge level. At the same time, he's really passionate about developing the developer communities and how to get the developers engaged so that we can actually leverage all of the knowledge of the developers to actually solve these big problems, right? So I just have a little bit notes with me of Kamal's profile here. So Kamal has, before joining Google, Kemal led the Facebook's virtual assistant program and the Messenger platform. That was one of the most incredible platforms that came at that time. And I personally used it in my business as well, and that was really exciting. You can actually talk to it like a virtual assistant, and that really narrows the sales funnel for many of the people, those people who have been using it for making sure that their customers are well informed and they go over the FAQs even before they start knowing about the product. And before that, he was with Bit.ai. Kemal graduated from, excuse my pronunciation in there, École Polytechnique and Telecom Paris, and holds an MBA from Stanford Graduate of Business School. So without further ado, let me add Kemal to the screen. Hi, Kemal. Can you hear me properly?
I can. Thank you, Arshan.
We cannot hear you. Can you check your mic settings?
Can you hear me now?
We still cannot hear you.
Okay.
And let me check if there's something on our end.
Hello?
All right. Yeah. Okay, we can hear you.
Okay, good. Because I couldn't change my microphone in such a short time, so I'm glad it's working.
No issue. All right. So Kemal, welcome to GDG Cloud Islamabad. I hope there are many people across the Pakistan that are actually listening to you. So we will take the question and answers in the end, and any question and answers from the audience will also be accumulated, and we can have a short Q&A session in the end. So let me just share your slides over here, and then I will exit, and then you can take it from here.
Sounds good. Thank you.
All right. Thank you, Kemal. Over to you.
Okay. So hi, everyone. Welcome to TensorFlow Everywhere 2021. My name is Kemal. I'm the product director for TensorFlow. And well, thank you for tuning in. I'm very happy to be here today virtually from California. The best part of my job is to meet the community and hear from the amazing things that you're building. TensorFlow Everywhere is a series of global events led by TensorFlow and machine learning communities around the world. We're dropping into these events over the next few weeks. And while we can't meet in person, we are hoping these virtual events are more accessible than before. Since the TensorFlow Developer Summit last March, which was a year ago, if you believe it, the last time our global community came together virtually, a lot has happened. Global pandemic, many of us experiencing changing personal circumstances, and just a new, different way of working. And so in times of uncertainty, it's core to who we are to turn to technology, like machine learning, to help. We found comfort in knowing that we're part of an important infrastructure for the world that has the ability to help others. And so, for example, within Google during these times, we've seen how TensorFlow played a really important role in supporting Google Meet, our video conferencing software. And you can see it being used as an education platform in the bottom middle photo. And TensorFlow helped the software adapt to changing bandwidth and enhance picture quality. Since making Meet's advanced feature free for all G Suite and G Suite for Education user in last March, we've seen daily usage grow by 30x, with Meet hosting 3 billion minutes of video conferencing daily. And this is just one example of how TensorFlow is helping us adapt and support new forms of communication and collaboration. TensorFlow has had a massive adoption, and we're seeing the users grow and accelerate. We're now close to 200 million downloads since we started, which is crazy. Our tutorials and guides content has been viewed more than 50 million times. There are more than 800,000 learners enrolled in our courses on Coursera and Udacity. So really, the first thing I'd like to say is on behalf of the TensorFlow team, a huge thank you to all our users and contributors who have helped build and improve this platform. Today, TensorFlow is much more than just a deep learning programming library. It's really a complete ecosystem. It's made up of libraries and extensions to help you accomplish your end-to-end ML goal, whether it's to do cutting-edge research on topics such as reinforcement learning, recommender systems, or music and art generation, or to apply ML in real world in production, or deploy machine learning on a variety of platforms, which we'll see later in this talk. So there's a tool for everyone and every need, and more are being added constantly. So today I will give you an overview of the entire ecosystem and share some recent advances in addition, covering the full ML workflow. TensorFlow has tools that help you define and build models, tools that help you understand, scale, and optimize your models, and tools that help you productionize and deploy your models, whatever your needs are. All of this is built on an underpinning of resources and practices to help use AI responsibly. And more importantly, the ecosystem is built and powered by you, the TensorFlow community. And so in this talk, I will cover all of these aspects. Let's get started. So let's start with model building. A little over a year ago, we revamped TensorFlow by launching TensorFlow 2.0. This was a huge milestone for us, bringing usability improvements and cleaning up of the API interface. We specifically focused on three main areas. First, to make TensorFlow easier and more intuitive, we focused on Keras-based API for simplicity when building and training an ML model, whether it's for research, experimentation, or production, and remove unnecessarily duplication. Second, we've made it easier to do large-scale research and development with TensorFlow, which has always been one of TensorFlow's main advantage, and get the performance and scalability benefits with this easy and flexible APIs. And lastly, we focus on making TensorFlow work on more platforms and for more use cases and applications. And since we launched, we've been hard at work to continuously improve TF 2.x. 2.0 was about eager execution, and offering a simpler high-level API with Keras. 2.1 brought TPU training with the same code, no code change necessary. 2.2 brought significant performance wins. 2.3 focused on better data and performance tooling. And the latest release was 2.4, was all about distributed training, making multi-worker synchronous training with mirror strategy more robust against deadlock. And TensorFlow 2.4 also brought support for CUDA 11, allowing support for NVIDIA's latest GPUs. And we're getting ready for 2.5, so stay tuned. And at the heart of TensorFlow is really bringing the cutting-edge research to all developers. You can see here some of the latest publications that were published use 2.x. So for example, here we see a real-time sign language detection model, and reinforcement learning using quantum circuits. What this means for you is that by using TF 2.x, you simply get usable APIs with state-of-the-art models. For example, the object detection API or the recommenders library that lets you create a recommendation engine in no time. In fact, for many users, one of the first things to do when implementing machine learning is to find pre-existing models for their use case. And so TensorFlow Hub is our one-stop shop for TensorFlow models artifacts. Today, we have more than 1,000 models available with documentations and code snippets. These models can be easily found by searching or exploring tfhub.dev, and you can filter based on your problem type or deployment platform. TF Hub also helps bring many of these models to life in a super interactive way. So some of our publishers, they've created custom components to highlight their amazing work when you can try out a model with your own image or audio clip to see how it works before downloading it and using it. So the slides, for example, shows some of these in-page visualizations. And you can run directly in the browser using Tensorflow Js with nothing to install and no data to send to a server. It's really cool. And many TensorFlow Hub models have interactive Colab notebooks links that allow you to play with the models in code right from the browsers. Powered by Google infrastructure, hosted notebooks and free GPUs, again, with nothing to install. So be sure to check this out. So after finding a pre-trained model in TF Hub, the next step is often to take that model and fine-tune it with your own data. Or you may want to train a new state-of-the-art model from scratch for your use case. For this, we have the TensorFlow Model Garden. So the Model Garden is a repository for official, well-maintained and tested high-quality implementations of many advanced models. It comes with source control and model checkpoints. These cover use cases across vision, language, and recommender systems, and include models such as BERT, EfficientNet, Muscar CNN, and many more. They're all implemented using TF2 best practices, making it really easier for you to build on top of it. The TF Model Garden also has a large and growing number of community contributors, and you can find a big collection of community contributed models here as well. Another new exciting addition to TensorFlow is TensorFlow Numpy. With TF Numpy, we have built Numpy compatibility right into TensorFlow, which means you can use more than 200 Numpy methods with TensorFlow accelerations on CPUs and GPUs. You can freely interop with all of TensorFlow's APIs. You can compute gradients and fast Jacobians, compile and auto-vectorize the code to get orders of magnitude speedups. And by using the Save Model interface, you can serve NumPy code in production on accelerators and mobile devices. So here's an example. It's a Hello World example to get started. You import TensorFlow experimental NumPy and start using it like a regular NumPy module. And so here we have two 2D arrays, and then we compute the product following by a sigmoid operation. And note that if a GPU is available, the computation will automatically be accelerated by it, as shown here by the print statement. TensorFlow implementation of NumPy will generally provide really good speedups on larger problems, although exact performance really depends on the workload. So here we're showing a benchmark for sigmoid computation, and the y-axis is time taken in milliseconds, and the x-axis is the size of the input vector. The blue line is time taken by NumPy, while orange line is that taken by TensorFlow on CPU. And so you can note that it's already faster thanks to TensorFlow's optimized multi-threaded kernels. Further, using TensorFlow's compilation machinery or running this on GPUs using TF NumPy provides even larger speedups. You can see here that for smaller size problems, NumPy might still be faster since GPU's round trip may be too expensive at this scale, but still a pretty nice speedup at large scale. So we've seen some of the new features and resources for model building. The next step in the ML workflow is usually understanding and visualizing model trainings, scaling the training to bigger data sets or bigger models, and optimizing the training process. As you probably know, Tensorboard is TensorFlow's highly popular visualization toolkit. It is used by researchers and ML engineers to visualize training and track and compare their experiments. It allows tracking of training metrics such as accuracy, visualizing model architecture, exploring model parameters, embeddings, and a lot more. But users who run many experiments have told us that it's hard to keep track of TensorBoard instances, let alone sharing them. So to address this, we now have Tensorboard Dev, a free hosted TensorBoard solution. You share your data logs with the service, and Tensorboard.dev provides the storage, organization, and presentation in the same familiar form. So this is really designed to make sharing easy, as you can now simply send a URL link to your Tensorboard to your collaborators rather than to share a screenshot of your local service. Another exciting new feature in TensorFlow is the Tensorflow Cloud Api. A powerful and easy way to train ML models is to use a hosted notebook platform such as Colab or Kaggle. Once you have a model set up in Colab, you may find that you want to train a much larger model on more data using more resources than you have locally or that Colab provides you. Or you may be a Kaggle user and you want to run hyperparameter tuning experiments to optimize your model with hundreds of runs using distributed training. Well, this is why we've built Tensorflow Cloud, and it's a new API to help easily push your Colab or Kaggle training experiments to Google Cloud's platform, AI platform, bringing cloud scale training at your fingertips. So getting started is really easy. All the cloud tasks are handled for you, and your model checkpoints and Tensorboard logs are all supported, so you can work with your environment and take advantage of training in cloud. So check out the setup and example notebook on GitHub. So for example, here's a code sample for an image classification model in a Colab notebook using familiar Keras APIs. We load the prepackaged data from Keras dataset with a finer model, and then we call model.compile and model.fit to train the model in Colab. Now, to train this model on Cloud AI platform instead, all we need to do is add 2 lines of code. So import TensorFlow-cloud and then call tfc.run. This will package your notebook code into a container, ship your cloud project, and execute a training job on Cloud AI platform. In order to use this, you just need to do a one-time setup of your cloud account and GCS bucket, and there are easy instructions in the notebook to show how that is done. Now, if you want to scale your training to a larger number of GPUs or other accelerators, distributed training is automatically supported. So we can set distribution strategy to auto, so TensorFlow Cloud creates a distributed training run for you, depending on the cluster configuration you specify. For example, here we're specifying that we want to use a T4 GPU as the chief and 10 T4 GPU workers. Using this, you can easily scale up to multi-GPU or multi-worker training with resources automatically provisioned. Another big use case of TensorFlow Cloud is to run multiple concurrent jobs with distributed training. For example, when you're trying to do hyperparameter tuning to improve your model accuracy and optimize it. This uses Cloud Tuner, which is based on the Keras Tuner API. So here on the left, we define our hyperparameter search space with parameters to search over and how many trials to run. In Colab, we would run this using tuner.search. With TensorFlow Cloud on the right, you can call tfc.run.cloudtuner, tell it how many concurrent jobs you want to run. Here we're using 10, and this will execute the hyperparameter tuning with Cloud's tuning service, and it will manage all the parallel jobs, checkpoints, and experiment results, greatly speeding up the process of running such tuning experiments. So we really look forward to you trying this for your next data science project. As we just saw, when we're using distributed training, it is really important to analyze performance of your pipeline and identify root causes of bottlenecks so that you can take action to address performance problems. So we have now added a profiler plugin in Tensorboard based on best practices used within Google. This includes a collection of tools listed here for profiling your models and pipelines. Results are analyzed and presented in plain English with corrective suggestions, such as shown here, that your program is input bound. You should focus on reducing input time. It is really easy to install and use this plugin in Tensorboard with this command line shown here. One of the new features in profilers in TensorFlow 2.4 is the ability to look at distributed training performance on multi-worker GPUs. So first, you need to specify the addresses of the worker machines that you want to profile and the duration of profiling capture. In this example, we have 2 workers and we're profiling for 1 second. After profiling is done, you can select the pod viewer tool from the side panel to compare elapsed step time between multiple workers for the training step you want to see. So you can see the detailed step time breakdown for each of the workers. And here we see that the worker on the left is slower, and the breakdown shows that it has longer kernel launch time. So we know what is the problem we need to solve for addressing any performance optimization. And this is really important when dealing with large models. Okay, so now I want to talk about the next part in the ML workflow, which is productionizing our model and then deploying it on the platform where we need to use it. This has always been a central goal and the core strength of TensorFlow. So as data scientists or machine learning engineers, we often focus on our models. This is natural because this is part where we research, innovate, and come up with creative ways of solving problems. But once we have a model, before using this in production in the real world, there are many other things we need to consider. For example, the data that the model encounters in the real world may be very different from when we train the model, and so our model does not perform so well. Or we may have complex feature engineering pipeline, and we want to make sure that those steps are, they're reproducibly used in production. At Google, in our experience, the modeling code is only 5% of total code necessary to train and deploy a model in production. All the other tools and infrastructure that you see here are critical to the success of a product or a service. So in addition to all the things we need to do from an ML development perspective, we also need all the things that production software deployment needs more generally. So in other words, we need to apply DevOps principles and best practices to machine learning. And to do all of this, we need a production infrastructure and process which is thoroughly tested and maintained. And TensorFlow Extended, or TFX, is built for exactly that, our solutions for putting ML models into production applications and services. So let's take a closer look. So this is a high-level schematic of the TFX platform. And there are many parts in the ML pipeline, and there are TFX components for all the parts. During training, you want to prepare and ingest data. You may want to export a dataset schema and distribution and validate new data against this. You may have some data transformation steps that you need to apply. Then you have model training components, followed up evaluation of the various model version, and then finally pushing out the model for serving on a variety of platforms such as server or even mobile devices and web. And then you want to reuse this pipeline during batch or streaming inference. So TFX provides tools for all these needs, making it easier to create, run, and manage these pipelines. TFX also enables tracking the metadata associated with your models and experiments. And it allows you to add your own custom components to set up a pipeline that is unique to your application. It is a very powerful and expanding set of tools. I definitely encourage you to learn more about it and try it out if you're not already using it. So another thing to consider is that today machine learning is used not only in data centers and servers, but on all kinds of devices and platforms such as mobile phones, IoT devices, and web browsers. By using TensorFlow on device and in the web, ML can power your applications and reach billions of users. There are many impactful use cases that can be built relatively easily using pre-made offerings. And most importantly, when running ML on device, all the execution happens client-side. So your user data does not have to leave the device, which is a big privacy benefit. So let's see how TensorFlow can be used on all these platforms. TensorFlow Lite is our production-ready framework for deploying optimized TensorFlow models on mobile devices and embedded systems. It's widely used by most Google teams and by a very large number of external companies and developers. And today it's on more than 4 billion phones. TensorFlow Lite is not just a model format and TensorFlow runtime for mobile devices. It's a complete solution of tools needed to build highly performance ML solutions for mobile. Over the last year, there have been many additions to TF Lite. So I want to mention a few of them. Model Optimization Toolkit is a set of tools to help optimizing your models for maximal performance. It now supports quantization-aware training for building models with better accuracy. It has also a new compression and size reduction technique. Apart from using off-the-shelf models, TensorFlow Lite users may also want to create their own models. So Model Maker makes it easier and supports customizing existing models using transfer learning with just a few lines of code. To make it easier to use pre-trained models for common ML tasks in your application, we have the task library, which provides easy APIs to wrap TF Lite models with a well-defined interface and use it in your app. This supports many use cases across vision and NLP. And lastly, to empower users with state-of-the-art models, we have enhanced the set of pre-trained models in TF Lite and published the corresponding reference apps as well to easily get started with integrating ML into their apps. And performance, performance is one of the most important focus areas for TF Lite. TensorFlow Lite offers best-in-class CPU performance through the integration of XNN pack library and optimized implementation of floating point ops. Here you can see 40 to 60% speedups on many devices for inference with XNN pack backend compared to the default CPU backend. Along with out-of-the-box best performance for CPUs, you can leverage TensorFlow Lite delegates to get peak performance and lower power consumption. TensorFlow Delegate APIs provides a convenient interface between the runtime and the underlying device accelerators to run faster computation on GPUs, NPUs, and DSPs. Also, quantized models are now supported by GPU acceleration as well. So another rapidly growing surface for ML is the web. And TensorFlow can be used on the web and other JavaScript platforms with TensorFlow Js. In addition to all the benefits or client-side and on-device ML that we talked about, web has the benefit of being ubiquitously present on billions of devices already, and users can run ML models embedded into web apps in browsers with 0 installs. Plus, TFJS is ideal for web developers who can now use ML with familiar JavaScript APIs. TensorFlow Js is a complete solution for ML on the web. You can use it to run existing pre-trained models that we publish or any TensorFlow or TF Lite model and run it with TFJS. You can retrain existing models directly in the browser. You can even author new models from scratch using a JavaScript API that's analogous to TF Keras. We provide many pre-trained models as shown here for common ML tasks. These models are wrapped in convenient high-level APIs so you can use them in your web applications with less than 5 lines of code. Check out our examples and demos in the model repo shown here. All these models can also be found on TF Hub. So we have recently added some new models to TFJS and enhanced some of the existing ones. For example, iris tracking in the fancy section model, and a new set of pose estimation models, and new NLP models for Q&A. We have also been making significant improvement with WebAssembly on performance and support for SMD with multi-threaded for CPUs, and improvements to WebGL performance on Android. And there's a new web-based benchmarking toolkit that developers can use to benchmark the performance of their model. Okay, so far we have taken a look at all the parts of the ML workflow, from model building to scaling and optimizing to deployment. And a really important consideration in ML development is to build and use AI responsibly. Let me show you what we mean by this. So here's a simplified ML workflow from problem definition to a deployed solution. Responsible ML is critical to all stages of this workflow. To build ML solution responsibly, there are many questions we need to ask and address. For example, is the problem in the problem definition stage? Who is the solution for? Are there any human biases that are reflected in my data? How can I train my models with fairness, security, and interpretability in mind? Once I've trained my model, what metrics should I use to evaluate the fairness of my models, and how can I prevent harmful feedback loops? In addition to fairness, another huge consideration is privacy. How can I train my model with privacy best practices, and can I test my model whether it leaks sensitive user data? Lastly, what is the information I should publish about my model in a model card that users should know about before using my model? And we provide a whole set of tools in TensorFlow to help answer these types of questions and include in your ML development, as are shown on this chart. For example, know your data and the what if tools for our tools for interactively exploring your data and discovering problem scenarios. TF Privacy lets you train your ML model with differential privacy techniques. Fairness indicators and TF privacy tests are ways to quantify metrics and risks for your models. And there's a lot more here, I know it seemed a bit overwhelming, but I really encourage you to dig into this very important part of ML development. And so to make it easier to find and use these tools, we have launched a comprehensive unifying portal for these tools, the Responsible AI Toolkit. Since its launch last year, we have continued to add more tools and resources to it. You can find more information at the URL shown here. And there are more than 10 collab tutorials to help you get oriented with the tools across various use cases, as well as technical APIs to help you get started. So we have taken an almost complete tour of TensorFlow, which brings me to the most important part of the TensorFlow ecosystem, you, the TensorFlow community. TensorFlow is powered by the thousands of contributors and developers who work with us to make it better and more useful. So let's take a look at some of these community initiatives. So one great way to connect is to join a TensorFlow user group. These grassroots communities started organically, and we now have 80 of them globally. And I'm sure this map could have a lot more dots. If you want to start a user group, I don't think there's a user group in Pakistan, but if you do want to start a user group, please reach out to us and we'll help you get started. And you have the email address here on the slide. We also have Google Developer Expert, and we really love our 160 plus GDEs. They give tech talks, they run workshops, they shoot videos and write articles for developers worldwide. And in 2020 in particular, the GDEs expanded their effort toward development projects that the AI versus COVID project released a very large COVID-related data set. So please reach out to your GDE as well to get started. They're really awesome. For bigger projects where we invite community contribution and ownership and leadership of parts of TensorFlow, we have created TensorFlow Special Interest Groups, or SIGs. And so the SIG program organize contributors into focused streams of work and take ownership of specific areas to add and maintain new features. So here's a full list of the TensorFlow contributor ecosystem SIGs, with TensorFlow Js, models, recommender systems, and a TFX add-on being the latest addition to the family. These SIGs are all run with an open design philosophy, whether they're led by Google team members or external community members. Each SIG meets on a monthly basis, and if you want to be a part of a SIG, you can head to the TensorFlow community GitHub repo for more information on how to join. You can also propose a creation of a new SIG about something that you want to lead and drive, and we're here to guide you through the process. Okay, so in an open source community, transparency is key. And so the RFC or request for comment are a great way to get feedback on large open source projects. This is the primary way that we communicate our design ideas and proposals and receive feedback before implementing a change. So if you want to propose a design, we strongly encourage you to socialize your ideas, recruit a sponsor, write your RFC, respond to feedback, and implement. And we promote new RFCs on our Twitter feed, so keep an eye on the TensorFlow Twitter account for that. Another really awesome initiative we have launched is the TF Community Spotlight program, which recognizes cool projects and demos built by the TensorFlow community. We select winners regularly and feature them on TensorFlow social media. To date, we have 18 winners that have been recognized. And you can see all the cool demos and amazing applications of TensorFlow by following the hashtag TF Community Spotlight on Twitter. So if you create something that you would like to highlight, or if you know of a cool project, please submit it to us at the short link shown here or via Twitter. We really love seeing those things. We're also investing a lot in educational resources to help anyone wanting to start their ML journey and learn about TensorFlow. We have a terrific content in official TensorFlow online courses on Coursera or Udacity, such as the TensorFlow in Practice, TensorFlow Data in Deployment, and TensorFlow Advanced Techniques courses on Coursera, and Introduction to TensorFlow and TensorFlow Lite on Udacity. We've recently launched the TinyML certificate with Harvard University and an Intro to DeepLearning.com course with MIT. Another really cool initiative is the TensorFlow certificate, which is a way to recognize developers as skilled and qualified in TensorFlow and help them demonstrate their proficiency to prospective employers, for example, or for their professional network. So far, we have more than 3,000 developers who have taken and passed the TensorFlow certification. So I definitely encourage you to check this out. And now I'm going to play a video to finish. I don't know if you're gonna hear the sound, let me know.
There's more extreme rainfall, heavy flooding, forest fires.
The Vatican archive, it will take centuries to be deciphering.
Air pollution is one of the major problems which Delhi people are facing.
Antibiotic resistance is everywhere. If we don't act today, we'll have 10 million deaths per year by 2050.
What I'm excited the most about machine learning is that it enabled us to solve problems that up to 10, 15 years ago we thought unsolvable.
Deep learning is almost perfectly poised for problems in climate science.
We can use machine learning in treatment and management of these respiratory diseases.
Using TensorFlow, we can tackle things we never thought we could tackle. That's like incredible.
We've shown that with a high productivity framework such as TensorFlow, you can get to massive scale and you can get like awesome performance and accomplish your goals.
Okay, so this wraps up the talk. Thank you again. As you can see, this is a really exciting time to be an ML developer. There are many ways to get started, build a great service or company, or bring change in the world. So thank you again so much for tuning in. And don't forget to join the conversation on social at #TFEverywhere2021.
All right. Thank you very much, Kemal, for this great presentation. And again, even though I've been working just on the sidelines, I'm not a core dev, but really exciting things that I've seen with respect to the TensorFlow. I really like the integration of the Numpy and the way that you can just, go to the cloud from just your native code. Like that really blew my mind, that you can just start a cloud, machine just directly from your code and have your code processed directly in the cloud automatically. That was one of the most amazing things that I've seen.
Yeah.
So we do have some questions from the community on the live stream as well as from the developer community that we have gathered before you came online as well. So I can take you one by one through the questions, and then you can share your insights in it. All right. So 3 questions. Basically, they are linked with each other. Who do you see as the main competitor in TensorFlow, or what are some of the companies out there that are providing similar services as the TensorFlow, and what makes TensorFlow better over them? And just a relation to that as well, that people have mentioned PyTorch in relation to TensorFlow as well, that how TensorFlow compares with PyTorch. So what are your opinion about that?
Sure. Yeah. Well, thanks for the question. So first of all, I think that it's pretty incredible to see how many solutions there are now since 6 years ago when we first open sourced TensorFlow, and we really think it's great, because at the end of the day, the reason why we open source TensorFlow is that we want to accelerate the progress of AI, and so it's really exciting to see all these different offerings that are now out there for users. I think all of them, they have sort of the plus and minuses depending on exactly what part of the ML sort of landscape you operate in. But I would say that, and so for example, you mentioned PyTorch, and obviously PyTorch has made a lot of good progress in research. But I think what was really great about TensorFlow, what I really like about it is really the ecosystem approach, right? So because as I mentioned in my talk, often we focus on the sort of the little the little yellow box of ML code, but then you have all the huge box around it, which is all the things that you actually need to do machine learning and to have it be useful and have impact in the world, right? So it's from all the different libraries that you could be using. You mentioned adding NumPy now and being able to just with one line of code being able to train it and scale it seamlessly onto cloud with absolutely no expertise whatsoever on how to do distributed training, which is magical, right? And then you're going to think, oh wait, I need this model to work on a mobile or on a microcontroller. Now a new thing that's happening is ML is getting everywhere in microcontrollers. We put TensorFlow models in Adidas shoes, which is crazy, right? And then you have also this huge deployment at scale, which is Google tested. So typically, Airbus has put TensorFlow on a satellite on the International Space Station, right? And so I think what you get on TensorFlow is really this ecosystem that guides you to the end-to-end journey. And so chances are that the reason why we're able to do this is that it's because it powers Google, right? So if Google has had an ML problem and has fixed it, it will be in this ecosystem of tools. And chances are that when you're encountering this problem, you will find a solution there in the ecosystem.
All right. One feedback, and I think your comment on this would be really appreciated in the developer community, is why is there sort of incoherence in the structure that the TensorFlow follows throughout their versions? Like, for example, if a code is written TF in TensorFlow 2.00, it can't run as it is on the newest TensorFlow or the latest TensorFlow. So this is one of the feedback that we are getting from the developers, that there are some backward compatibility issues within the code.
Okay, so if it's from 2.0 to 2.5, we'd love to hear about it. So if you could maybe ask those developers to share more details, and we'll be happy to look into it. The 1.x to 2.0 obviously has been a big migration, and there has been a breaking change there. It was sort of inevitable for us to have to do that because the organization of the code base when we initially open source, it was new, right? So everything was getting invented, and so as often in those kinds of projects, then you don't necessarily know the best organization at the time. It was 4 years into our journey, we started seeing, okay, well, this is really how we should get things organized. There were also a lot of, I think things in contrib and things like that we needed to clean up. This was, by the way, the biggest ask from our users was really, hey, please help us clean up the API and bring us something that's much easier. And so that's really why we focused on 2.0. And yes, there's been a breaking change. On the other hand, we've put together a lot of resources to help you migrate your 1.x code to 2.x, and I'm happy to share more details on that.
So it will be preferable for the developers to actually run it through these kind of tools that can actually sort of refactor your code into the latest TensorFlow environment.
Yeah, so if you're on 1.x, right? I mean, if you're on 2.x, then the code should work well with new versions, and happy to look at any examples that the community could share with us. All
right. So one other question with respect to PyTorch is that how come the TensorFlow does not have an error stack just like PyTorch, and if we can see this kind of thing in the coming future?
Does not have
an error stack. So
yeah. Okay, so yeah, that has also been a huge ask of giving more interpretable, less mysterious error messages. And definitely, so I think this is one of the problems that we had with complexity in 1.x. It was difficult for us to be able to deliver on that, and And so there's been really huge improvements in the 2.0 stack. With being able to trace the error and give you sort of human readable messages on what the error actually means. But recognize that it's also something that, again, because it's a full ecosystem that allows you to do all these things, then we want to keep getting better on that aspect. And so similarly, like if there are some error messages that you find are still cryptic or not helpful, it's really great to share it with us. It's really helpful because then we know exactly what are the things that are the most painful, and we get that feedback, and then we can focus on improving it.
All right. So let me club some of the questions together about the mention of cloud computing, leveraging the power of the cloud computing with respect to TensorFlow. So one of the questions, let me just flash it on the screen as well, was by Mohammed Abu Bakr. TensorFlow benefits with the edge computing, and we use the TensorFlow with the edge computing. And one of my queries that I can further on add to it is that can we have TensorFlow Lite on non-Linux based embedded devices, or will it just only work with the Linux based kernel?
So sorry, so was the question about edge computing in general, or specifically? Right. So
you can just answer the edge computing first, and then we can go into the details.
So I think to me, edge computing is really one of the most exciting areas of application of machine learning, right? Like if you go back in time and you look at the IoT, the craziness, and everybody was like, oh, we're gonna raise a lot of money and do all these things on IoT. Well, one of the problems with this is that those remote those IoT devices, they consume power. They need network connections, and they have to be smart. Right. If you just anytime you see, for example, you have a camera, anytime you see a move, you send a video stream, then your IoT strategy is not going to work. Or if you want to put like a device to, I don't know, listen to the audio on a pipeline, or like all those ideas, they really needed actually AI to work. And it's only now that you can build these smart devices that will only react based on something that they've detected locally, right? And so I think that is something that I see as a huge unlocker for the IoT world, and things that will in preventing maintenance, but also in healthcare, and those things, as I mentioned, they're getting smaller and smaller, right? So now, I mean, we wouldn't have just 5 years ago putting an ML model on a microcontroller or like a little chip that cost $2 was just crazy. And now you can actually do that and have an audio model that lights up when it hears a sentence, right? And so I think this is one of the huge strength, in my opinion, of the TensorFlow ecosystem, is the ability to run these on-device models on phones. By the way, like even small feature phones to like obviously full-fledged phones on IoT and also on the web, right? So a lot of the phones, there's a whole strategy around running web apps, whether it's in messaging on messaging platforms, which I know well, or just on feature phones who have browsers. Now with TFJS, you can do just that, right? You can just code a web app and have it target those small devices. So I think again, like I view this as a huge area of innovation going forward. And your other question, your other question was running TF Lite on non-Linux devices?
Non-Linux based processors or kernels.
I don't know specifically the answer to that. So maybe if we can follow up offline, I'll be happy to get you someone who knows that answer.
All right. One of the key questions that came from the community is that the TensorFlow features that were mentioned, do they require to be integrated with the Google Cloud services, or can they work with other cloud networks as well?
So that's a great question. So TensorFlow is an open source framework, right? And so that means that you can take TensorFlow and you can run it on your machine, on Colab, on premise. You can run it on cloud. You can run it on other clouds. There is no, this is really an open source package, right? Now, with that being said, TensorFlow is part of Google, right? And so Google Cloud obviously has worked specifically on making TensorFlow more optimized on Google Cloud. So there's a version of TensorFlow that's called TensorFlow Enterprise, which is optimized to run better on Google Cloud. So, and then you have these other collaborations like TensorFlow Cloud, which we mentioned, which is you're like you said, and I think this is really fantastic. So I'm just going to say it again. Like literally, you're in your Colab or you're on your local machine. You add one line of code, and now poof, it gets in a container, and gets magically sent to cloud, and then it will scale on distributed training, and you could do hyperparameter search, etc. So these kinds of collaborations, cloud will specifically target TensorFlow and say, well, hey, this is the technology that they use as well, right? All Google uses TensorFlow, so that's the technology that Google Cloud uses as well for ML, and so there's a natural synergy here.
All right. So again, just on the same sort of bandwidth, we have got a question from the Kaggle community. Is TensorFlow support available on the Kaggle kernel and with the TPU or without the TPU?
Yes, yeah, it is. And actually, sorry, excuse me a second. So it is absolutely available. Actually, one of the big questions wanted to be asked from the community when we released 2.0 was to be able to not have to write specific code for specific accelerators, right? Like, why do I have to write one code for GPU, one code for CPU, one code for TPU? That doesn't make sense. And so that was one of the reasons too why we built TF2. And so TF 2.1 was the first release where the same code worked for GPU and TPU interchangeably. And so now, if you use TF2 on kernel, you can ask your code to run on TPUs and get take advantage of these really, really amazing accelerators. And TensorFlow Cloud, for example, you can do the same, right? You could say, well, I'd like to be using TPUs on cloud and just do that. And I believe we had a Kaggle competition. It was a little over a year ago, when the winners actually used cloud TPUs to win the contest. So yes, they're available and they're very easy to use.
All right. So one last question from the community is that, or rather a feedback as well, that the integration with the local GPU is a bit of a challenge for them. So they are looking forward to if the community-based APIs can be enabled so that they can quickly integrate with the local GPU that is available on their own machine.
Yeah, that's a great question, actually, and there are multiple ways that we can help with that. And so I think I'm going to take that as a follow-up. If you have, if you could connect us with the folks who are interested to do that, I can follow up on that and connect them with the right folks within the TensorFlow team.
All right. So one last thing, because you are already here and we have got you here. So what are the most exciting things that we can see in the upcoming, let's suppose, the next 6 months and the next year? Because this is from the developer community as well as the community watching you online right now. They want to know what's the next big advancement that we could expect in TensorFlow.
Sure. Well, I already mentioned one, which what I believe is the Edge ML. I think the use cases in like I said, in health, like with these microcontrollers, you could basically wear a wristband or have something that monitors other metrics and really do some give you insight or give you some really smart feedback. There's a lot of things in sports that are pretty incredible as well. So just that general area of Edge ML, I think, is really exciting. Another one that I still think is really early is just the democratization of machine learning. I think right now, like I believe, I'm sure you and the audience is part of like a small knit group of folks who like really follow this. But like imagine what's going to happen when the tools, the tools keep getting simpler and simpler, and they're embedding incredible research. And so I believe that we haven't seen yet the full explosion of ML in the larger industry. So I think, to me, like, I wouldn't take my eye off that ball, because I think that one is really, really where the actual impact of AI would completely be unlocked for society. And then I would say the last one is probably like very large models. I think that very large models with language is something that's pretty incredible what's happening. And there's obviously I've worked on assistants. You mentioned it on chatbots and things like that. And I think something like when you look at the exponential progress in this area, some pretty incredible things are going to happen there too. So all in all, I think it's a very exciting time to to be an ML practitioner. So yeah, those would be the three that I would think about.
I think it goes without saying that with respect to the Google's policy of the next billion users, I think there will be the next million programmers as well, and then we need to consider them as well.
Yes, and I think, again, like, to me, this is the power of a platform, right? A platform really connects the state-of-the-art researchers and what they do and what they build, and it wraps it into a set of tools that developers and builders go apply it in the real world, right? And this is why we get so excited about things like the online courses, the certificates, so that you can go and say, look, I am proficient in those technologies, and I can solve your problems. There's again, like the TensorFlow user groups are something that we're really excited to see, and we're happy to support. So if someone, again, like a call to action, like if someone wants to create the first TensorFlow user group in Pakistan, please reach out, and we'll help you get set up.
We will definitely link you up with the people who are already working in TensorFlow and would be really excited with this opportunity. And directly on that same path, because you have got your hand on the pulse of the developers, what kind of TensorFlow users do you see? What kind of metrics do you see from the people in MENA and South Asia region, and especially from Pakistan? How many of the developer communities that you have seen, or developers that you have seen, come out of Pakistan?
Yeah, so we don't share those specific numbers for obvious reasons, but we're definitely seeing a very strong growth. And I think, like, well, I'm originally from France and Morocco, but I grew up in Morocco, and to me, it's an incredible time to be an ML developer, because if you have an internet connection and a good laptop, you can get all these educational resources for free. You can access, like accelerate, like on Colab. Colab is incredible. Like, you just fire up a web page, and then you have all this free computation. This is the same, GPUs and TPUs that the world, like the leading researchers in the world, are using in Google, and you get access to this for free, right? And so I think this is where I think the superpower of developers around the world can really shine, because there's much less friction and limits to it's really like the work and the time spent and the imagination and creativity that you can put in. And if you similarly, like if you create something that's really interesting and cool, just reach out to us. I think I shared the hashtag, and then we'll amplify it, and everybody will know about it, right? So I think, to me, that's also something that personally makes me very excited. And when I was invited to to meet you and speak to the audience. I was just personally very excited to go say, look, I mean, get on that train, go do it. You could, this is.
And same, we were excited to host you as well.
Thank you.
All right. So with this, if you have any feedback to give to the community, like how can they be more engaging, how can they actually contribute more, do let us know, and we will share that with the community in the GDG Cloud, not only just Islamabad, but overall in the Pakistan region and the South Asia region as well. So again, Kemal, thank you very much. Any closing remarks that you would like to give?
I believe I sort of said it all again. Like, thank you for having me today. Just like go build and tell us about what you're building, and really we want to help.
Yeah, on the same lines, all I say is that you just need to know the problem. There is a solution out there somewhere. You just need to find it. All right. Thank you very much, Kemal, for your time, for coming on the platform, and for engaging the community and sharing us with the exciting things that are coming in TensorFlow, the exciting things that are happening right now, and how developers can actually use that to actually solve the real world problems that we are having, and make a very impact oriented business or decisions and whatever they want to build. So it's up to the developers how they want to use these tools. So thank you very much, Kemal. Thank you very much.
Thank you. Have a good evening.
All right. Bye. All right. So I hope this was a really exciting, live stream for you. It's a very rare chance that we actually get the, product manager or product director directly from Google and engage with the audience over here. So one last announcement before we sign off. We have noted down the names of the people who have been selected for the giveaways, and we will be contacting them soon to note your address down and ship the giveaways. So thank you very much again to all the audience for engaging, and hope to see you. And in case if you have any queries, GDG Cloud Islamabad webpage is online, and you can just message us, and if we will be able to relay all your queries related to TensorFlow to Kemal and his team directly as much as possible, and we will get back to you with the answer. If you have any other query in any of the cloud domains, be it the GCP platform or machine learning or AI, don't feel free to reach out anytime, and we will try to help as much as we can by linking you with the experts, by linking you with the developers who are already working in this technology. So thank you very much again for coming to this live stream, and this is Arshan signing off.